Good afternoon, my chemistry minions. Time for the last installment of lecture videos for Unit 1. Woohoo! The one and done. If you are watching this video, you are on page 30, going to finish with 31. We are going to learn how to measure and calculate density, the measurements needed for density, and then how we do calculate it. All right, first we're going to compare mass and weight. Mass, of course, is how much matter something has. The weight of something is how much matter with gravity. So there is the difference right there. They are similar though, because as mass increases, my weight will also increase. Okay, my wife's been telling me that for so long it's not even funny. All right, we will really just work with mass in chemistry class. Remember, we will have the same mass whether we are on Earth or on the moon. Earth, of course, has gravity. The moon has much less gravity, where you can, I've seen videos of them walking and they can take real big giant steps, right? Because there's a little bit of gravity on the moon, but not very much at all. All right, measurements we need to take. So if I'm going to take volume measurements, how much space something is, I'm going to use a graduated cylinder for liquids. If I have a regular shaped solid, I'm going to measure its length, width, and height with a ruler and do my calculation. If I have an irregular solid, something that's round, I can use the displacement method. Remember the initial volume in my graduated cylinder and the final volume in my graduated cylinder. If I subtract the initial from the final, I will have the volume of what I put in that cylinder. Now, density, of course, is the amount of mass in a given space. Okay, so it's a ratio because I'm going to divide the two. The formula, density equals mass over volume. We all know this. We've learned it in 8th grade. Probably use it again in 9th grade and definitely in earth science. It will be in table T in our reference tables. And let's look at these two boxes, A and B. Which one has the higher density? Explain your answer. Which one do you think? Mr. Monaco, which one do you think?
I think it's box A.
Box A.
Yeah.
Why? Just because A comes before B?
No, I think it's box A because there's like more atoms inside the same amount of space. So it's
Oh, very
parts like packed in there real tight.
very observant that you saw that the boxes were the same size and there's more of them. So yeah, more mass and the same amount of volume. So A is definitely more dense. Good job, Mr. Monaco. Thanks for helping out. Density of water is 1 gram per milliliter. Little thing to know here, 1 milliliter is the same as 1 cubic centimeter. They're the same thing. Okay, so if I say 1 gram per milliliter or 1 gram per centimeter cubed, same thing. The first would be a displacement method versus what we would call the length times width times height method. Okay, but if I take 1 gram and divide it by that 1 mil, right? 1 gram divided by 1 milliliter, I get 1. 1 divided by 1 is 1. So that's it. The density of water is always 1, of pure water. So now we know how to use each measuring tool to get the data I need to calculate density. I can think back to the lab because we did this in our measurement lab and in our density lab. We prepped for both kinds of measurements. There are so many practice problems on doing density that I can't list them all here, but if you need some practice on density, you're still not all that sure, do it. Do it till you can't get it wrong. Do lots of density problems. I will see you guys in class. Last lecture video is done. Woo-hoo!